Well, hey there, mathletes. Today we are looking at inverse trig functions. So inverse trig functions are a way so that we can find measures of the acute angles in our right triangles. Okay, so we'll see that inverse trig function when we have a -1 to the power. This sine inverse is also referred to arc sine. Okay. Note that when we are finding these, we'll definitely need to use our calculators for many of them. So when you're looking at your graphing calculators or your scientific calculators, notice that most of your inverses are going to appear as options for your calculator above your sine, cosine, and tangent buttons. So you have sine inverse above sine, you have cosine inverse above cosine, and tangent inverse above tan. When you're using the inverse trig function, notice the difference in structure. Our sine, okay, we would always say the sine of some angle equals the sine value. So this would be our ratio. So sine is SOHCAHTOA, so it's opposite over hypotenuse. Okay. Well, now with our inverse trig function, what goes in here is your sine value. So this is your opposite over hypotenuse. Okay, you do the inverse sine of that. Okay, and your answer to an inverse sine is an angle. Okay, so this will help us solve for these unknown angles in right triangles. So let's see how we're going to utilize these. Okay, so this should look familiar. We have determined which of the two acute angles has a cosine of 0.15. So remember, cosine of um, cosine of some angle is equal to 0.15, or the same thing as 1/2. Remember, cosine is adjacent over hypotenuse. So I look over here. This is a special right triangle, I notice. So I have 1, 2, square root of 3. So I know this is coming from my 30, 60, 90 right triangle, where this angle here, okay, is 30. Here is 60, and there's my 90. So which angle has an adjacent side of 1 and a hypotenuse of 2? Well, here's my side 1. The angle that is adjacent to it, that's not my right angle, is this angle B. So I can say that my angle B, okay, which is 60 degrees, is the angle that has a cosine of 0.5. Okay, so that's using special right triangles. So with our inverse trig functions, the nice thing is our acronym SO, CA, DO, A still works for our inverse trig ratios. So notice sine, inverse sine, is going to be BC over AB, where BC, okay, remember this is all dealing with angle A here, so BC is the opposite side, and then we have our hypotenuse AB. So we see BC is our opposite side over our hypotenuse, okay, and that coming from sine. Cosine, okay, notice AC is our adjacent side, and again, our hypotenuse is AB. Okay, and then same thing for our tangent. So we're anticipating O over A. Well, from angle A, BC is our opposite side, and AC is our adjacent side. Okay, so let's see how we can utilize these to solve problems. Okay, so we want to find angles A and B. So if I know the tangent of A equals 0.75, I can write this as the tangent of 0.75, the inverse tangent, 0.75 is equal to A. Okay, so I use my calculator, okay, and I turn it on, and I want to make sure that I have So inverse tangent. So I got to do my second tangent, 0.75, close my parentheses, and what I should be anticipating is an angle. So this angle, angle A, and we want to go to the nearest tenth, so that's 1 decimal place. When I look at that, that's 36. 86 is going to round up, so I got 36.9 is the angle that has a tangent of 0.75. So if I want to solve for B here, okay, what angle gives me a sine ratio of 0.87? I can say sine inverse of my ratio of 0.87 is equal to what? So using our calculator, we're going to say inverse sine, okay, 0.87, and we get 60 point, well, after the 4 is a 5, so that tells us to round up, so we're 60, so angle B is equal to 60.5. So if we're looking at them as a triangle, a right triangle, okay, we're going to have to decide on which inverse trig function we want to do if we're trying to solve for an angle. So I always inform my students, if we're trying to solve for an angle, we should be thinking inverse. So sine inverse, cosine inverse, or tangent inverse to find angles of right triangles. So notice on all of these examples, our angle is the x at which we're trying to find. So then we have to decide which of the 3 trig functions are we going to use with the given information. So what I like to do is I label my sides just like I would if I was trying to solve for a side. So I look at the 2 sides, I look at my angle, identify my right triangle, my right angle, and I know that 7 would be my opposite side, and 14 is my adjacent side. So which trig function deals with opposite and adjacent? Again, if we have SOHCAHTOA up here, okay, I notice that O and A deals with tangent. So I want to do tangent inverse because I'm solving for an angle. In tangent inverse, remember O is our numerator, so that's 7 over 14. Adjacent is my denominator. So using my calculator, I have inverse tangent of 7 over 14, and we get 26.6. So always good to go to at least 1 decimal place. So 26.6 degrees. Okay. So for my next problem, identify, there's my angle I'm trying to find. My right angle's here. So this side is my adjacent side of the that angle. And 18 is across from my 90 degrees, so that's hypotenuse. Well, so which trig functions deals with A and H, adjacent and hypotenuse? I see that's cosine. So since I'm solving for an angle, I want to use the inverse cosine. And inverse cosine adjacent is my numerator. My denominator is my hypotenuse. Okay, so then I use my calculator. So inverse cosine of 8 over 18. And I get x being 63.6. Okay, so now for my final one over here, again, I look at my x here, right angles here. So then side 10 is my adjacent side, and B is my opposite side. I don't know my hypotenuse. So again, which trig function is going to be dealing with opposite and adjacent? Well, opposite and adjacent is tangent, so we're going to do inverse tangent. Okay, and inverse tangent opposite over adjacent. So as I use my calculator, I do inverse tangent of 8 over 10. And I'm going to get 38.7, rounding appropriately. So x is equal to 38.7. So now that we've used Pythagorean theorem, we've used our trig functions and our inverse trig functions, we can solve for a right triangle. We can solve for all the missing unknown side lengths and angle measures. What we need to know is at least two pieces of information to be able to decide to find the other parts of a right triangle. So as long as we know it's a right triangle, if we have two side lengths, we can solve for all the missing parts. And if we know one side length and one of the acute angles, we can also solve for all the other missing parts. As you'll see as we walk through these, it's kind of mathematician's choice on which ones you need to utilize. So again, in recap, we should know that we can use our a squared plus b squared equals c squared, our Pythagorean theorem. Okay, we can use sine, cosine, and tangent to solve for missing sides. Okay, we need to know an angle. Okay, and then we can use sine inverse, cosine inverse, okay, and tangent inverse to solve for missing angles. Okay, and we need to know the two sides. Okay, so that's kind of our big ideas from this trig unit here, all kind of coming together. Okay, so if we're trying to solve for all the missing parts of this right triangle, okay, I notice I have two sides, a 3 and a 2. So if I want to solve for c, I can use my Pythagorean theorem. Okay, and I can say that 3 squared plus 2 squared equals c squared. Okay, 3 squared is 9, 2 squared is 4, c squared is just c squared. I have 13 equals c squared. So c is equal to the square root of 13. If I use my calculator, I get square root of 13 being 3.6. Okay, so now I need to solve for my angles. Well, if I'm solving for angles, I need to use inverse trig functions. Well, if we know that this is 3.6, I could really use any one of my trig functions if I pick the right side. So, for instance, let's say if I want to solve for b. So you just need to make a choice and say what angle you want to solve for. Okay, in my opinion, I don't like to use 3.6 because just in case I made a mistake down here, I don't want it to affect all my other answers. So I'm going to stick to the values that I know that were given to me, the 3 and the 2. Okay, so if I'm solving for this angle B, I recognize that this 3 is adjacent to my angle B and 2 is my opposite. So what trig function deals with A and O? If we think about SOHCAHTOA, that is tangent. So if I'm trying to solve for an angle, I do tangent inverse. Okay. Tangent is opposite over adjacent. Okay. So as I do that, I do second tangent, 2 divided by 3, and I see that I get an angle. So angle B is equal to 33.7 degrees. Okay. Well, we've got the three sides known, 2 of the 3 angles. We still need to use angle A. Okay. So the other thing that we also know is our angle sum theorem of a triangle. So if all 3 angles add up to 180 degrees, I can do 180 minus the 90-degree angle I have because it's a right angle, minus angle B that I found, which is 33.7, and I will get my remaining angle, which is 56.3. Double check that at 56.3 plus 33.7 should be complementary. They're 90 degrees. So sure enough, angle A is equal to 56.3. Notice, if I didn't want to use my angle sum, I could have done a similar thing with my inverse tangent and recognized with angle A here, 2 is my adjacent side, and 3 is my opposite side of angle A. So if I do inverse tangent of 3 over 2, okay, in my calculator, I also get 56.3. So there's going to be multiple strategies that we can go about solving these. Okay. So again, let's solve for the right triangle. So I have 2 missing sides and I got a missing angle. So again, I like to focus on the things that I know. Okay. So right here, okay, if I want to solve for a side, let's start with G. So G is adjacent to 25, and I know 13. I don't want to other unknowns, so I don't want to deal with H right now, but I want to deal with 13, which is my hypotenuse. So what trig function, SOHCAHTOA, TOA, that deals with A and H? Well, that's cosine. Well, I'm solving for a side length, so I don't want to use my inverse, so I want to use cosine of 25 is equal to A over 13. Solve for A, I'm going to put this over 1, cross multiply, and I get 13 times the cosine of 25 equals A. Using my calculator, I do 13 times the cosine of 25, and I get A is equal to 11.8. Okay. So next, let's solve for H. Okay. H is here. Again, I want to focus on what is given to me. So if I'm given this angle of 25 degrees, I want to use that. And H is opposite, and I know my hypotenuse. Yeah, I know A, but again, if I made a mistake here, I don't necessarily want to use that value in my problem solving for further ones, because I could get, if I had A wrong, it's going to get my other answers wrong as well. So identify this stays as my hypotenuse. O and H is sine. Okay, so I can say sine of 25 degrees is equal to H over 13. Just noticed a mistake in my variables. I was using A for adjacent, where this is actually side length G. Okay, so now solving for H, putting this over 1, cross multiplying, I get 13 times the sine of 25 equals my H. And I see that we end up getting a value for H, which is equal to 5.5, rounding my answer to the nearest tenth. So the last thing I'm getting is my missing angle G. So I could use my angle sum for G, but I want to try and use my trig, as that's what we're practicing this unit. So let's use the 2 sides that we found. Okay, and if they end up giving me the correct answer and the same answer as the complementary to 25, then I've kind of know I've done G and H right. So for angle G, okay, my opposite side is side length G, and my H is my adjacent side. So O and A is tangent. So if I do tangent, again, I'm solving for an angle, so I want to do inverse tangent. Inverse tangent, SOHCAHTOA, opposite. So my opposite side is my G, 11.8, over my adjacent side, which is my H, which is 5.5. Okay, so if I do my inverse tangent of 11.8 divided by 5.5, I see that I get an angle of 65 degrees, which, if I'm making sense of my answers, 65 and the angle 25 are supplementary, so then I know I've done my answers and my solutions make sense. Okay, for our final example here, dealing with some word problems. Okay, so our school is making a rake stage, just meaning that the performers are going to be slightly leaned forward for better viewing of the audience. Okay, so the stage length is 30 feet long, so that's from here to there. Okay, the actual platform that they would stand on. The total rise is 2 feet. Okay. You want to make sure that the rank to be 5 degrees or less for the safety of the performers. Okay. So is the rake stage within your desired range? Okay. So since I'm finding an angle, I should know I'm using inverses. So here's my X there. My right angle is over here. So I label my sides hypotenuse. I don't know my adjacent side, but I do know my opposite side of that angle X. So O and H, if I'm thinking about SOHCAHTOA, right, there it is, O and H is coming from sine. So if I'm solving for an angle, I want to use the inverse sine of my opposite side over my hypotenuse. And I can type that into my calculator. So inverse sine of 2 over 30. Okay, I get equal to 3.8. Okay, that is 3.8 is less than our 5 degrees. So yes, it's within our safety range. Okay. That's going to conclude our notes today on inverse trig functions. Please highlight any questions you might have and bring them to office hours.